the Titan IIIe Centaur, seen here dwarfing the locomotives parked at the pad. On August 20, 1975, that massive launch vehicle cleared the tower in Florida, pushing Viking 1 into an 11-month silent cruise toward the Red Planet. The engineered survival architecture remained dormant during the transit, waiting for the specific physics of the Martian orbit to trigger its systems. When Viking 1 entered orbit in June 1976, the mission immediately hit a crisis. The planned landing site proved far more heavily cratered than Earth-based observations had suggested. Descending into that terrain risked a catastrophic crash. Rather than proceed blindly, mission controllers delayed the landing. They spent weeks using the orbiter's cameras from space, painstakingly scouting safer terrain across the planet. They locked onto a new target, Chryse Planitia, or the Plains of Gold. As this topological map shows, the new region offered a significantly flatter profile compared to the surrounding craters, which was critical to ensure the lander wouldn't roll over on contact. By utilizing the orbiter as a reconnaissance platform, the team proved that rigid plans were a liability. Flexibility and real-time observation became their first successful survival tactics. Was a site chosen, the lander had to actually reach the ground. The Martian atmosphere presents a unique engineering contradiction. It is thick enough to cause extreme friction and entry heating, but too thin to rely entirely on parachutes for a soft landing. Decelerating through this environment required a multi-stage approach. First, an aeroshell coated in a cork-like ablative material absorbed temperatures reaching 1,500 degrees Fahrenheit as the craft punched into the upper atmosphere. Second, at an altitude of 4 miles, a massive 16-meter parachute deployed at supersonic speeds to violently bleed off the initial velocity. At 5,000 feet, the lander was still falling too fast. The parachute and aeroshell detached, and active retro-rockets ignited to take over the final descent. A standard rocket engine would have blasted a crater into the dirt or incinerated the soil samples scientists wanted to study. To avoid this, engineers developed these specialized terminal descent engines. Each uses a cluster of 18 small nozzles to disperse the exhaust laterally, gently lowering the craft without destroying the landing zone. The 7-minute descent stacked these distinct engineering solutions to counter the specific, layered threats of the Martian atmosphere. On July 20, 1976, the spacecraft touched down. Because of the vast distance between the planets, it took 19 agonizing minutes for the telemetry confirming the landing to cross the solar system and reach NASA's Jet Propulsion Laboratory. The very first command executed on the surface was to take a picture, intentionally angled downward at the dirt. Engineers needed immediate visual proof of the ground's stability and the physical condition of the lander's footpad. The image formed slowly, scanning line by line from left to right, revealing rocks, coarse sand, and finally the spacecraft's own circular footpad, resting securely on the surface. That single photograph shattered the Mars curse. It provided the empirical proof humanity needed that a spacecraft could safely arrive and operate on another world. With survival achieved, the mission turned immediately to science. Housed inside the lander was its primary scientific payload, an automated biological laboratory designed to search for microbial life. To ensure that any detected organisms were authentically Martian, the entire lander had been sealed inside a pressurized bioshield and baked at 232 degrees Fahrenheit for 40 hours before launch, eliminating all terrestrial contaminants. The lander scooped up soil, injected it with nutrients, and analyzed the results. The data revealed unexpected chemical activity and off-gassing, but it ultimately lacked the definitive signatures of metabolic life. These ambiguous, highly debated results forced researchers to reconsider the complexity of Martian surface chemistry. The challenge of interpreting the soil data contributed to a 2-decade pause in surface missions to Mars. Viking 1 operated for over 6 Earth years. It delivered our first close-up view of the rocky Martian plains, and its meticulously engineered survival architecture laid the definitive blueprint for every rover and lander that has followed. Thanks for exploring with Cosmora HQ. Please like, comment, and subscribe. Share this with your intellectual friends.